Okay. I know a couple of you. Ranvi is gone for some school stuff, right? Okay, all right. And then Suhani, I got a message saying that you were not able to try the homework problems due to
Yeah, my
exams,
school just started, so
school stuff. Okay, all right. Okay, occasionally it's fine, but in general, guys, please, I'm not just for her, I'm just telling everyone, be on top of your homework. It's very easy to just fall off track. If you leave 1 week and that's it, it piles on more and more and more, and it's always difficult playing catch up. Okay, all right. So with that, let's start. Let me bring up last week's homework. We were to finish discussing the first homework. I mean, first homework as in from the permutation combination, we had a few more to discuss, if I recall, right? Okay. What's that? Okay, any doubts in general, guys? Some basic concept doubt or anything that was not very clear last time?
Sir, I didn't get like the homework 7, how to proceed towards it. I did homework 6.
Okay, you did homework 6, but you did not get homework 7 meaning?
Like I got all the questions in homework 6. I did most of them.
Yeah.
Homework.
But you were not able to attempt.
Yeah.
Oh, you were not able to solve.
I was not able to attempt this. I tried attempting, but like I couldn't like understand.
That's fine. As long as you tried hard enough, that's all I'm looking for. And obviously with the class discussion, things will be better, right? As opposed to not trying at all, this is definitely a good, right? Okay, don't worry too much about it. We'll discuss. So question 4 from homework 6. So let me just paste it here. Are you guys able to see my screen share, guys? All of you good on this? Drishit, did you do this one? How to approach this one? Question 6, question 4.
Yeah, 1 second. I'll just open my book. 1 second.
Yeah, have everything ready, guys. So be ready to kick off as soon as class starts. Water, homework, this, that, everything. Washroom break. Finish everything and be ready.
Oh yeah, so I didn't get this one.
Okay, Yuvam, your hand is up. Tell me.
Sir, I got the answer.
As?
Sir, actually, I got 2 answers,
Okay.
but both of them have like a 0.00 something difference.
Okay. Tell me your 2 answers, please.
Yeah. My first answer is 5 upon 9.
5 upon 9. Okay.
And the second answer I didn't simplify. It's 10 choose 2 upon 20 choose 2 times 20 choose 2 upon 30 choose 2.
Okay, like this, right? So obviously you can cancel off the 20 choose 2, right? Do you agree? If this is your answer, we can cancel off. And let's quickly work it out. It should not take too long, right? 10 choose 2 is 10 into 9 by 2 into 1, right? And then 30 choose 2 is 30 into 29 by 2 into 1. So effectively the 2 and 2 gets cancelled there also. Are you with me so far? The cancellation so far? Yeah, Yuvam, you with me?
Yes, sir. Sorry, I was on mute.
Oh, okay. Sorry, I was not able to see you either. So this is 3 and this is 3. So based on your second answer, it's 3 by 29, which is not very close to 5 by 9 as you were saying, right? One answer is 5 by 9, one answer is 3 by 29. You're saying the two were very, very close by 0.00001. What does it mean? They're quite off, right?
Sir, when I did 10 choose 2 upon 20 choose 2 times 20 choose 2 upon 30 choose 2, I got 0.539.
0.539. How so? You're seeing the, okay, you can check your simplification. Simplification, I'm leaving it to you, but you can see in front of you, I just simplified. 20 choose 2 cancelled off. It really boiled down to 10 into 9 by 30 into 29, which is 3 upon 29. Okay, all right, let that be. Simplification, I'll leave it to you. Sanvi, does your answer match any of his answers? Sanvi Sheth.
yeah.
Yeah, does your answer match any of Yuvam's answers?
Yeah, I got 3 by 29 too.
You got 3 by 29 too. Okay, all right, let's discuss. Okay, let's discuss. Anyone else with a different answer? Navya, what did you get?
I'm sorry, I'm not sure about this question.
Okay, but you attempted, but you did not get anywhere with that. Is that what you're saying, Navya? Okay, all right, let's discuss. Right, so you have a number line, and then you have 0 sitting here, let's say, right? 0 sitting here, and then this is 10, and this is minus 20, or rather, the coordinates of this point is 10, 0. In fact, there's only x-axis, right? I don't even need 2 coordinates, so I'll just say 10. So I'll just say this is 10 on the number line. This is the point 0, and this is the point minus 20. Okay, I'll erase this minus 20. Okay, so the length of, so in other words, the length of this is 20 and the length of this is 10 units. I'm randomly picking up a number from this interval, right? Now, what is the probability that the product of these numbers is greater than 0? So if both are plus, the product will be greater than 0. If both are minus, then also the product will be greater than 0. So the question is really saying the two numbers should both be positive or both be negative. Now it's easy, right? For both of them to be positive, right? It's a fraction of 10 over 30, right? You can randomly put a line, put a point anywhere in the infinite points of a length 30, of which you have a probability of 10 by 30 of selecting a positive number, right? You close your eyes, just get a baby to pick some point. It does not know anything. It'll just randomly pick something with a 1/3 probability. It'll be a positive number. Similarly, you ask the baby to select another point. It'll do another point in 1/3 probability of selecting a positive number. So in that case, the product is positive, or both being negative. So it's 20 by 30 into 20 by 30. So it's a sum of these. So it's 1 by 9 plus 4 by 9, which is indeed 5 by 9. So your first answer was fairly straightforward, was correct. Sanvi, can you, what did you do to get 3 by 29? Can you explain, please?
No, I messed up in the calculation.
Okay. Okay. So, but is this exactly what you did here?
Yeah, I got
Okay.
it. Yeah.
Okay. All right. And back to Yuvam. There won't be any choosing here, Yuvam, because it's an infinite continuum of points. It's not like you have only integers where you have to select from. You have two real numbers. Real numbers are like the continuum of numbers, right? You can pick any two real numbers. So it's not like there are, in fact, we can change the problem to be, in fact, can all of you do this? Two integers. I'll change the, so this problem is clear. Whatever we did right now is clear. Aditya, you're okay in this one? Okay. Now,
So if it would be integers, then 3/29 would be correct.
okay, if maybe it is, maybe it is not. Can all of you work it out, saying it is two integers? Okay, if you're confident, then you don't have to work it out again, Yuvam. But everyone else can work it out in case you're confident. Only change, changing the real numbers to integers. And the question exactly remains the same. Can you all work it out? I'll give you 30 seconds.
Do I simplify?
Sorry, say that again.
Simplify the answer?
Yeah, go ahead, Navya. What is your answer?
No, I'm saying, should I simplify it?
Yeah, if you can simplify, please. Yeah, please simplify. It should not be too difficult to simplify. Yeah, but go ahead, please. Yes. Okay. Anyone? Arya, you have anything?
No, I didn't get this.
Okay, Veer, you have something, or should we discuss, guys, or you're okay? Want some more time?
Still calculating, so.
Okay. Whoever has simplified can call out your answer. Anyone?
So I got 47 by 87, but I'm not sure that's right.
47 by 87. Okay. All right. Okay. Let's discuss. We have given enough time for everyone, right? So first of all, so two questions come up. If it's integers, right? So is minus 20 included? Is plus 20 plus 10 included? And the answer is in the question itself. It's a square bracket. If you put a square bracket, those points are included. Now, for real numbers, it did not matter because you had infinite points. So literally 1 point did not make any difference at all. But when we are talking integer points, it really makes a difference whether we have 20 points or 21 points. I'm just saying an example. In this case, whatever, 30 points or 32 points, whether or not you include the ends or whatever, right? So in this case, that question is answered by putting square brackets. The second doubt that you generally have is, if I select 7 as the first number, now can I select 7 again as the second number? What do you think, Suhani? So can I select 7 and can I select 7 again? Do you have
Yeah, I think you can because it says independently.
Excellent. That's the right word. Selected independently, right? If the word independent were not there, then in the moment you select 7, and which means if you're restricting the second selection to be 7, it cannot be 7, it can be anything else, then there's dependence, right? But the question says it's selected independently, which means, again, you're asking the baby to select an integer point and then select one more time, select an integer point. It could be another one, it could be the same one, doesn't matter. Okay, so these 2 points are important. Now let's approach the same way. For the product to be, first of all, what is the denominator? The denominator is all the possible 31 numbers. Minus 20 to plus 10, there are 31 numbers. So the first selection the baby does could be any one of the 31 numbers. The second selection can be any one of the 31 numbers. Of this, right, the favorable cases are both being positive, as in 1, 2, 3, 4, so 1 till 10, right? No 0. So 10 into 10 plus minus 1, minus 2, so on till minus 20. Both negative because the answer question is greater than 0. If 0 is one of the numbers that we choose, again, the product becomes 0, and that's not what we want. We want the product to be strictly greater than 0. So 20 into 20. So this becomes the numerator. So overall, what do we get? 500 upon 961. 31 square is 961, which is why I said you should be able to simplify it quickly now. Yeah. Okay. So 500 by 961. I don't think that simplifies to 47 over 87 or anything, right? In fact, 31 is 5. Yeah. Navya.
Yeah, no, it doesn't simplify.
Okay. Is your answer worth still discussing, Navya, or you found your mistake, or maybe just lesson for others to learn? What did you do to arrive at 47 by 87?
I didn't count. I didn't put 31 in the denominator.
Okay, so you put 30, is it?
Yeah, and then I did 10 choose 2 plus 20 choose 2.
Okay, you did 10 choose 2 plus 20 choose 2.
Yeah, and then divided choose 2.
Divided by 30 choose 2. Okay, I see. 10 choose. Okay, so that will be the answer if 2 integers are selected, 2 different integers are selected, rather, right? Or in other words, you pick an integer and then that's it. That integer is already picked. You cannot pick that again. And then you pick another integer. Then what you're saying would be right. Does it make sense to everyone? Right? So dependence versus independence. That's as Suhani rightly pointed out. Given it's independent, that means the same point can be picked up. In what Navya wrote, it's a solution to the question if there's dependence. Right? All of you okay on this one? Arya, you're with me? Okay, cool. Next question. Question 5. This is my... Okay. Pair of dice, 6-faced dice is rolled once. Sum of the numbers determines the diameter of a circle. Okay. What is the probability? The numerical value of the area of the circle is greater than the circumference of the circle. Okay. All right. Let's see. Veer, what did you get on this one?
So I didn't get this one. I wasn't able to figure it out.
Okay. Sanvi.
Same.
Okay. Suhani, go ahead. See your hand is up.
So I got 1/12.
1/12. Okay. Okay. Anyone agree? Yuvam, do you agree with her or got something else?
Sir, I don't know how to do this, but like whatever I did, I got 29/36.
29/36. Okay. Arya,
I also got 1/12.
1/12 as well. Okay. All right. Let's discuss. Right. So first, forget about the die. Let's see what it takes for numerical value of the area to be less than the area of circumference. Right. I wrote greater than. So we want area to be less than the circumference. So let's write it. So pi r square should be less than 2 pi r, or rather let's write it in terms of diameter, because that role is going to determine the diameter of the circle. So I'll replace r with d by 2, so it becomes d square by 4 should be less than 2 pi times d by 2. Okay, so let's simplify this. 2 and 2 gets cancelled, pi and pi gets cancelled, so d square is less than, of course it's all positive numbers, so we don't have to worry about cross multiplying and all that. D square is less than 4d, which means d must be less than 4. The diameter must be strictly less than 4, and it's the sum of two numbers, right? So the sum of two numbers in a die can be start from 1 plus 1 all the way till 6 plus 6. So 2, 3, 4, 5, 6, 7, all the way till 12, of which we want the sum to be either 2 or 3, because we want the sum, which is the diameter, should be strictly less than 4. So the only options left are 2 and 3. So what is the probability of getting a 2 as the sum? You must get a 1-1 combination in the two rows. What's the probability of getting a 3? You can get a 1 under 2 or a 2 under 1. So these are the only 3 cases of the 36 cases that are possible in a double roll of a die. So indeed, it's 1/12. Well done, guys. Whoever got 1/12. I think Arya and Suhani. Yeah, does it make sense? Fairly straightforward, guys. We would have thought we should have done this, right? Veer, what is the problem?
Yeah, so I figured it out now as you explained it.
Yeah. Yeah, sorry, Drishit, you're saying something.
Yeah, so but if it's only rolled once, then are they talking about the like sum of the
Yeah. Oh, sorry. A pair is rolled once, same as rolling a die twice, right? Same thing, right?
Oh, right, okay.
A pair is rolled once.
Yeah.
So I said a die is rolled twice, same thing. Okay. By the way, for a die roll, the probability will be maximum for it to get a 7, right? So the probability will gradually increase. Getting a 2, getting a 3, getting a 4, 5, 6, 7 will be the maximum probability. And then 8 will be same as 6. Getting an 8 will be exactly same as getting a 6. And all the way down to 12. So getting a 2 is as likely as getting a 12, because these are extremes. The only possibility of getting a 2 is a 1 and a 1. Only possibility of getting a 12 is a 6 and a 6. Likewise, it will be symmetric. 10, 9, right? So 5 will be same as 9, 4 will be same as 10, 3 will be same as 11, 2 will be same as 12. And all of them will add up to 36. Sorry, all the probabilities will add up to 1, right? So everything will be 1/36. So this will start with 1/36. This will be 2/36, as we just saw. 2 cases for it adding up to 3. 3/36. We can quickly do it, right? 4/36, 5/36. Getting a 7 is the maximum possibility. 6 out of 36, because you have the combinations 1, 6, 2, 5, all the way till 6, 1. Right? So those 6 out of 36. Now let's quickly add up and see. On the rising side, you have 1 plus 2 plus 3 plus 4 plus 5, plus the peak, which is 6. And then plus again on the falling side, it's 1 plus 2 plus 3 plus 4 plus 5. So when you do 1 plus 2 plus 3 plus 4 plus 5, we get 15. 15 times 2 is 30. So they add up to 36/36, which is 1. Okay, so just a quick thing, right? With the die problem, you should immediately know all of these basic facts. Immediately, you should know that 7 is the maximum probability. You must know about the symmetry and how things rises and how it falls after that. Because there are a lot of die-related probability problems you can make up. Okay, Ranveer just joined us. That's good. Ranveer, are you back at home? Are you able to turn on your video, or you're still traveling from school and stuff from your match?
Wait, so what did you say, sorry?
Are you at home right now, or are you still traveling back home?
Oh, no, I just came home. Sorry about that. It was
No,
fun.
that's fine. I got a message, but as feasible, turn on your video after you settle down. But we'll continue.
Yeah, I'll just, yeah.
Okay, that is question 5. Question 6. You are all clear on this one? This question, the die problem?
Yeah.
Okay. Okay, I would have thought all of you should have got this one. So my only suspicion is you guys didn't try hard enough.
Sir, I counted 4 and I forgot to subtract the whole thing from 1.
Okay. Okay, no problem. Okay, dartboard in a regular octagon is divided into regions. Suppose the dart is thrown on the board, equally likely to land anywhere on the board. So the total probability is 1. It will land up anywhere. So you can be assured that it will land within the board. It's not going outside the board. So given that situation, what is the probability that lands within center square? So all of these are just ratios. Whenever you have a continuum of possibilities, as in we saw a number with real numbers, infinite points are there. Here also infinite points are there, but it's just ratio of lengths or ratio of areas, right? That's how you determine probability. Arya, any luck with this one?
I got 2 over 4 plus 4 root 2.
2 over 4 plus 4 root 2. Okay, all right. Yeah, I can sense there'll be a root 2 here because of octagon and all that. Okay.
Or I think I have a more simplified answer.
Go ahead, please.
With root 2 minus 1 over 2.
Root 2 minus 1 over 2.
Yeah.
Okay, I'll go with this one then. The simplified answer. Okay, anyone else agree or disagree? Navya?
Yeah, I got
Yeah, Veer.
yeah, I got a very similar answer, but my answer was square root of 2 minus 1, the square root of 2 minus 1, that's it.
Just square root of 2 minus 1 without the divide by 2.
Yeah, even I got square root of 2 minus 1.
Okay, so 2 people got this. 1 person got this one. Okay, all right. So at least you guys are fairly close. Maybe thoda aage piche here and there. Let's discuss, right? So right now it's very obvious that we want the proportion of this square of the total, right? Okay, now multiple ways we can either keep, see, it doesn't say what the length of the octagon is because it's all relative. I can keep it as 10 kilometers, I can keep it as 1 micrometer, doesn't matter, right? But whatever is easy, we can pick, right? Pick something as 1 or 2, whatever you want. Let's say I pick this as 1. So my numerator becomes easy. It's just 1 into 1. Something will suffer. If you pick the convenience for denominator, the numerator will require simplification. Either way. So let's go with this. So this is 1, 1, 1, 1. The area is 1. Now, this is 45 degree, right? You guys know that an octagon, each angle is 135. How do you know that? Because it's 180. First of all, easy way is 180 by n is the external angle. So 180 by 8 is each external angle. Sorry, 360 by n. What am I doing? Each external angle is 360 by n. So 360 by 8 is each external angle, which is 45 degree. So this angle is 45, which means the internal angle is 135. But that's enough to show that each of them is 45. So which means what? Okay, so first of all, if this is 1, all of the sides of the octagon all become 1, 1, 1, 1, right? 1, 1, 1, 1. Okay, I don't have to mark everything, but anyway. Okay, now in each 45, 45, 90, you know the ratio is 1 is to 1 is to root 2. So this has to be 1 by root 2 and this has to be 1 by root 2 for it to be 1. Because we need to honor the ratio as 1 is to 1 is to root 2. Root 2 being the side of the hypotenuse. Since the hypotenuse is 1, the two sides become 1 by root 2. All of you okay on this one? This much? Okay. Right? So now what is the area of the entire big octagon? I mean, only one octagon, that the single octagon. It's the center square, which is 1, plus you have 4 of these squares, right? 4 of these rectangles, I should say. So 4 of these rectangles, each of length 1 and width 1 by root 2. So this is 1 by root 2. Okay. And then you have 4 of these triangles. 4 of these triangles, each of them having a length and height of 1 by root 2 and 1 by root 2. Okay. So this becomes the total octagon area, right? So 4 triangles, each of the area half into 1 by root 2 into 1 by root 2. Let's simplify this. Root 2 into root 2 is 2, and 2, 2, and 4 get cancelled. So this is, in all, this is just 1. The 1 at the center, and then this simplifies to 2 root 2, right? 4 goes in root 2 as 2 root 2. Do you agree? So it's 2 into 2. One of the 2 will cancel as root 2. So the denominator is 2 plus 2 root 2. Right? If I'm doing some silly mistake, please catch me, guys. So 2 plus 2 root 2. Okay. So now the numerator we know is 1. So the answer is 1 upon 2 plus 2 root 2. Okay. Let's simplify this a little bit because we don't want to leave we don't want to leave roots in the denominators ideally. So first of all, I can write this as 2 into 1 plus root 2, or root 2 plus 1 rather. And then I multiply by the conjugate. And the conjugate is typically the such that it's a positive number, right? In the denominator, I want root 2 plus 1 into root 2 minus 1. So that it becomes 2 minus 1, which is just 1. And then, yeah, these the people who got root 2 minus 1 upon 2 are right. So, sorry, in fact, I think Arav, you're the only one who got divide by 2. The other two did not get the divide by 2. Is it? Or Arya, was it? Okay.
Me.
I always confuse between Arya and Arav. First of all, the names are same. The voices are also very similar, at least to me on the mic. Okay, but well done, guys. Arya, well done. Okay, but did you guys find your mistake? Whoever did not do the divide by 2? Sanvi, did you find your mistake? You found your mistake as well, Sanvi. Do you want to share with class? You have a quirky smile there. What happened? No?
What happened, sir?
No, you had a weird, wicked smile. What was the mistake about the 2?
No, sir, I just made a calculation mistake again.
Okay. All right. Guys, again, it's message for everyone. It sounds very cool to say silly mistake, calculation mistake, but it's all part of the game, guys. I can afford to do silly mistakes. I can afford to do calculation mistakes because I don't have any pressure. I'm just teaching you guys. But you guys should really take things seriously. Like, think as if this is the exam, right? Every homework that you attempt, even at home, I mean, be casual, be cool and all that. Don't stress out, but give enough attention so that you don't do silly mistakes, right? It's not cool to say I did silly mistake, right? Ultimately, the person who's going to correct will not know whether you conceptually knew and did this last bit of silly mistake or you did not. So ultimately, that's what is going to matter, right? So please exercise caution, guys. Okay, all good on this one?
I have a question.
Yes, go ahead, Swani.
So like this probably wouldn't work, but like, could you try like dividing the octagon into like equal parts and then calculating the center square? Or is that not possible?
I did not understand your method. Please go ahead. Can you elaborate your answer?
Like, could you divide the octagon into like equal parts so then you can calculate the probability by just counting the like fraction of the center square of the whole, like out of the whole octagon?
If it's just a round number, it works out, right? But in this case, it's not. For example, what you say might work. For example, if I have a triangle and then I have some small triangle like this, then you can see there are 4 of them. You can literally hand count, right? In this case, there's not integer number of center squares in the entire octagon. We have roots and all that, right? You're not going to be able to do pictorially like that. Yeah.
Okay.
Yeah, but good thought. Okay.
Sir, I also have a similar question.
Yes.
So since I understood, I got the same answer, but at first I got the answer as 1/9 because I just thought since it says it can land any of the 9 squares in it's equally likely to land. Why can't it be 1/9?
Because all the angles are not equal, right?
Yes, but it says it's equal to land anywhere, so it's equally as likely to land on a smaller square than the center square.
How so? How so? What is equal? What is equal about this? I don't know. Where did I keep my pen? There it is. Yeah. What is equal about this?
Suppose the dart is thrown, it's equally likely to land anywhere on the board. So wouldn't that, if it's split, I just thought of it, if it's split into 9 different parts, it can land in either part in equal.
Okay. It said equally likely to land at any point on the board among the entire area. For example, let's say the board was something like this, like the extreme case, like a big rectangle split into 2. And if the question said the dart is, let's say this is 1 unit and this is 9 units and this is 2 units, something, right? And what is the probability it lands in the small unit? Wouldn't you say it's 1/10? If the question said it's equally likely to land anywhere on the board, right? You would say it's 1/10, right? What he means is this point, this point, this point, this point, this point, this point. It's equally likely to land in any of those infinite points, not in any of those regions. It's equally likely. He didn't say it's any of the regions is equally likely.
Oh, okay.
Okay, that's the message. Yeah. Does it make sense, guys? Yeah. Okay, that was question.
Oh,
Yeah.
root.
So
I didn't get
you're
how
saying
did you
that
get
it's
the
a
Sorry, one of you. Drishit, why don't you go first?
so basically what it's saying is that it's that it won't be a coincidence where like that 2 points which align on the same spot, right?
2 points lying on this.
Like
I didn't.
meaning two darts that will lie like that will hit at the same spot. It's saying that that won't happen.
But
Basically.
anyway, in this question is only one dart, no? You're probably
okay.
confusing. Oh, you're probably confusing the other one where we picked 2 points on the real line and all that. Here, there's only one dart.
Okay. So
You're
but then what's the point of saying that?
saying what?
That it's equally likely to land anywhere, because if there's only one dart, then
No, one dart equally likely to land in any of the infinite points within this octagon. So,
okay.
right, the octagon has infinite points, right? So basically, I'll erase it, right? So if you randomly close your eye and drop the dart, it could lie here with some probability, here with some probability, here with some probability, here with some, here. All of these are same probability, all of them infinitesimal, but adding up collectively to 1. Right? Is as
Okay,
likely to
yeah.
land up in any of those infinite points. That's it. That's all he's saying. Does it make sense? Yuvam,
Okay.
your question.
Sir, how is the ratio of the triangle 1:1:2 or root 2?
In a 45, 45, 90, we went over this in the beginning of a geometry, right? So for 45, 45, 90, this is isosceles, right? Let's say this is A and this is A. Just by Pythagoras theorem, this is root 2 times A, right? A square plus A square, uska root, which is root 2 times A. Agreed?
Yeah.
Therefore, the ratio becomes 1:1:root 2. So in this case, this was 1. Therefore, this is 1 by root 2 of that. Does it make sense?
Oh, so they both are the same. Okay, got it. So,
Yeah. Okay, 45, 45, 90 and 30,
no,
60,
but
90.
both of them are the same, the A and the A.
No, I'm saying whatever A is, A could be 10 kilometers, A could be 1 micrometer. In my problem, I chose the hypotenuse to be 1, and therefore this has to be 1 by root 2, and this has to be 1 by root 2. Had I chosen this as 3, for example, then this would be 3 and this would be 3 root 2.
Okay.
I can choose whatever I want, right? It's all relative. He didn't say the octagon's length or anything, right? Whatever I do.
3 root 2, why 3 times root 2? Why not 3 upon root 2?
What are you talking? If this is A, this is A times root 2, right?
Yeah.
Yeah, so if I pick A as 3, then this is 3 times root 2, right?
Yeah, correct. Got it.
Yeah. Fundamental, guys, very basic question. Yeah. I mean, it's good that you're asking, but if this is very important, if in a 45, 45, 90, if this is any length B, then this is B root 2. I keep changing variables just to say that it does not matter. That's another way of saying it does not matter. Why did I select 3? Just to say that it does not matter. Whatever I select, accordingly, the other one will adjust. Does it make sense? All of you okay, right? Even you're okay, completely okay, right? Okay. And similarly, given that he has asked this, 30, 60, 90 is another popular one. All of you should know this because it comes over and over again. And 30, 60, 90, if this is length C, this is C times root 3, this will be 2C. 1:√3:2. That's the ratio in a 30, 60, 90. 30, 60, 90. 30 degree, 60 degree, 90 degree. Okay. Ranveer, hope you are settled by down to turn on your video. Okay. Did you do the homework, Ranveer?
Oh, yeah, sorry.
Or you had exams too, like Suhani?
Oh, no, I just forgot to turn it on. I'll just turn it on.
Oh, okay. Can turn on the camera. But the other question I asked, did you do the homework, Ranveer? Or did you have exams, school exams as
Oh,
well?
no,
Like,
so I wasn't able to get to school.
okay. You had school exams as well, or what was the reason you did not do the homework?
Yeah, no, I did.
You did. Okay. All right. Can you help us with question 7? Bernardo randomly picks 3 distinct numbers. Were you able to try this? Yeah, Ranveer, were you able to try this and get an answer on this one?
So I haven't tried it yet, but I was just reading.
Okay. All right. Anyone else? Navya, did you get an answer on this one?
No, I tried it. I didn't get an answer though.
Okay. This is a little on the harder side. Anyone with an answer to share? We'll anyway discuss in detail. Suhani, you have an answer? Oh, you said you did not try. Veer, you have something? Aditya, you've been quiet today. I didn't ask you. Sorry. That's why you've been quiet. Any answer on this?
Like in this question, I got stuck on like how do you compare their numbers in that part.
Okay. All right. All of you read the question completely, right? Any doubt in understanding of the question? Anyway, we'll read it together. B and S, right? B randomly picks 3 distinct numbers, right? 3 distinct numbers. Obviously, repetition is not there. Distinct numbers. Arranges them in descending order. So let's visualize. So let's say he picks numbers. He picks numbers 2, 8, and 4. Then he'll arrange them in descending order to form the number 842. And this guy S will pick 3 random numbers. Let's say he picks 5, 8, and 1. And then he'll arrange in descending order 851. Now these two numbers are compared, 851 versus 842. Right? What is the probability that Bernardo's number is larger than Sylvia's number? In this example that I gave, Bernardo's number was less than Sylvia's number. So you don't even want equality. You want Bernardo to be strictly larger than Sylvia. Okay, that's the ask. Now, there's an advantage that Bernardo has because he gets to select from 1, 2, 3, so on till 9, whereas Sylvia gets to select only from 1, 2, 3, so on till 8. Okay, first, let's do this problem. Before doing the question on the board, I will change this question. I'll erase this 9. I'll erase this 9. So it's a fair game, right? It's a fair game. With this, what is the probability that Bernardo is larger than Sylvia? You don't have to have an answer, but I want to just open it up for discussion. How would you approach this one, Navya? So it's right now symmetric, 8 and 8. So both, it's a fair game. Now, what is the probability of Bernardo being larger than Sylvia? Can you answer this one, Navya?
Maybe just be half because both of them have an equal probability of
You're
getting.
almost right, but it won't be half. Why will it not be half?
Because they can be equal numbers as well.
Exactly. Yes. Right? Because you can, so this guy can end up choosing 3, 8, and 1. The other guy can end up choosing 1, 3, and 8. So both of them, when you arrange, it's 831 and 831. They are equal. Right?
Minus 8C3, right?
Sorry.
It'll be half minus 8C3.
Almost right. HC3 is HC3 is the numerator of that, right? Oh, what did you say? Half minus?
8C3.
HC3, just imagine, what is HC3? HC3 is 8 into 7 into 6 by 6. It's a number like 56. But you are close. I don't think you meant that. You meant something else instead of HC3. What did you mean?
I'm not sure.
Okay, all right. I'll let all of you think. What is the probability of B greater than S in this problem that I have on the board with the 9 erased off? Can all of you take 45 seconds to do this? And she already gave fair amount of it. She talked about some subtraction. We all agreed that equal probability, probability of B greater than S and probability of B less than S are both same. These two are same. Okay. And then there's a probability that B equal to S. So collectively, all of these will add up to 1. That much we know. Okay. So with that, can you solve for B greater than S? What I've written on the board is clear to everyone. Aditya, you're clear, right? What I've written. So the 3 components, B greater than S, B less than S, and B equal to S. The greater than S and less than S are equal by symmetry. Okay, total dead silence here.
So is it, I got an answer,
Go ahead, Yom.
but I'm getting in negative, I'm not sure. I got half minus 6 choose 3.
Okay, 6 choose 3 is some choosing, right? The number of ways in which certain thing can happen, right? So you meant probably subtracting a probability from half, not number of ways of doing something. So find out what the probability is and subtract that, no?
Mm.
Veer, any idea?
Sir, I got an idea.
Okay, go ahead, please.
Is it half minus 6 choose 3 upon 8 choose 3?
Okay, all right. If it is, so be it. Tell me, explain. Okay, at least it's reasonable to discuss. What is 6 choose 3? What is 8 choose 3? What is this half minus? Explain the whole thing to me.
So like 6 choose 3 because 8 choose 3 is the denominator because you need to choose 3 numbers from the 8 digits possible.
Who needs to choose 3 from 8?
Bernardo.
And Sylvia also needs to choose, right? Both of them are selecting 3, right? Okay, Aditya, you want to take over from here?
So it's half minus the probability of B is equal to S. So
Half minus probability that B equal to S.
yeah.
Okay, so okay, why is it that? Why is it half minus probability B equal to S?
So because for it to be like, so like Navya said that only the it has to be half minus the equal number. So only then can you find that how many like B the number of the probability that B's number is larger than S.
No, it is not. Okay, so you're making a small mistake, and she also made that small mistake initially, right? Navya. Okay, so okay, this is the probability. Where is my red color? Okay, so this is the probability that I want. Let's call this probability P. We agree this is also P. Okay, and let's say this is the two probabilities being equal. We'll call it small e or something. So we know P plus E is 1. So the P that we are seeking is 1 minus E whole upon 2. It's not half minus probability that are equal. It's 1 minus what's the probability they're equal? Whole divided by 2, right? So it's rather, it's not this. It's 1 minus the probability that both are equal divided by 2. You understand the difference, Aditya? Okay.
Yeah.
So that's the first step. Now, what is probability that B equal to S, Aditya? How do you get probability that B equal to S?
Is it 3 upon 8 choose 3?
Okay, explain. Why is it 3 upon 8 choose 3?
So because the total outcomes is 8 choose 3 and the favorable ones are 3. Like
Why is the total outcome 8 choose 3? Same question I asked you. Who is selecting 3? Bernardo is selecting 3, you're saying, or this 8 choose 3 stands for which guy?
The total thing is 8 choose 3 plus 8 choose 3 then.
Why is it plus? Why not into? This guy can select any 3. For each of those, this guy can select any 3, right?
Yes,
Why
sir.
are you adding 8 choose 3 plus 8 choose 3?
Yes, so it should be multiplication.
Okay, so now what are you eventually saying now? You're not, it's okay. I'll restart. Whatever you dictate, I'll write. But you have to explain what you're calling out.
So it'll be 3 into 3 upon 8 choose 3 into 8 choose 3.
Like this?
Yes, sir.
3 into 3 upon 8 choose 3 into 8 choose 3.
Yeah.
Okay, explain what this is to me.
Because so I'm a bit confused between two things. It's either this or it's either 3 upon 8 choose 3 into 8 choose 3. So in this, so I'm thinking like the favorable outcomes have to be the same numbers. So then I'm confused that do we take the outcomes as 3 or do we take it as 3 into 3?
Okay. First of all, why? Okay, forget about the 8 choose 3 for a second. Why the 3 in the numerator? Whether it's 3 or 3 into 3, whatever it is. Why 3?
Because we need to pick 3 numbers that are equal in both the cases.
Yeah, but I don't understand why the 3 has to come like this? You're choosing 3 from 8, but the 3 itself stands for what? I don't understand.
So because like the numbers are equal, so it has to be any 3.
Numbers have to be equal, so it has to be any 3. I'm not convinced. Are you convinced, or are you taking a
So yeah,
shoot in
even
the
I
dark?
think I went wrong somewhere, so I just think.
Okay, fine. Okay, I want exactly that. I want a lot of confusion. Only then clarity will come. So all of you are thoroughly confused now. That's good. Okay, now let's discuss, right? So again, let's visualize, right? Bernardo is picking up some randomly 3 numbers. Let's say he selected 4, 1, and 7. Okay, now Sylvia has not picked yet. Bernardo has picked 4, 1, and 7, right? So we are only worried about the collection, the choosing. The ordering will automatically come. He's going to arrange it in descending order as 7, 4, 1. Work. How many ways can Bernardo select 3? That's 8 choose 3. So in 8 choose 3 ways, Bernardo can select some 3 of the 8, right? That we all agree. Now, for Sylvia to match that, his collection of 3 must exactly match. So he also has 8 choose 3 possibilities of choosing, but unless he selects the same set of 3, the probabilities will not be equal. Therefore, it's simply 1 upon 8 choose 3. I'll repeat it again. There are 8 choose 3 ways in which you can select triplets of numbers from these 8. Bernardo comes and selects one such triplet of the 8 choose 3 triplets. He has selected 4, 1, and 7. Now it's Sylvia's turn. He could also pick any one of the 8 choose 3 triplets, but you're asking him, no, you have to pick the specific triplet that Bernardo picked up, which is the combination of 4, 1, 7. The ordering does not matter. He's only choosing. There's no ordering here, right? So he has 1 in 8 choose 3 short. Are you guys convinced with this logic? Navya, are you convinced?
Yeah, so
Everyone is convinced? Aditya, you're convinced now with this logic? Yuvam, are you? Yuvam,
So
are
I
you?
have one question.
Yes.
The triplets, for example, if Bernardo picks 4, 1, 7.
Yeah.
Sylvia could pick 4, 1, 7, 7, 1, 4, or 4, 7, 1.
That's all I'm saying. So Bernardo's only choosing. So 4, 7, 1 and 4, 1, 7 will not get counted as 2 separate entities in Bernardo picking also. It's just a collection, right? In fact, I'll write 4, 1, and 7 like this. He's picking 4. He's picking 3. There's no concept of ordering at all. Like this, there are 8 choose 3. Let's write out 8 choose 3, which is 56. There are 56 such circles, right? So there are 56 such choices that Bernardo could have picked up. So in another triangle, it will read 2, 8, and 1 here. Another circle will not read 4, 7, 1 because 4, 1, 7 is already counted. So it'll read something else. It'll read 1, 3, and 8, right? And so on. There are 56 such circles, right? 56 of them. There are 56 of them, right? Of these 56, the 2 have to pick the same, which means the first guy picks something. He has total freedom. The second guy is forced to pick that. So it's 1 on 56. Okay. So just to complete, so the probability that for this problem is now 1 minus, we just saw it's 1 over 56 was the probability that B equal to S was 1 over 56 upon 2. Okay. Simplification we can always do. It's 55 upon 112. Okay, but we'll keep this number. This will come in handy. It still does not answer the original question. We have answered the question when Bernardo, with the framed question where 9 was not there. Okay, all right. So I'll stop this question with this one because this question is dragging for too long, but I'll definitely come back to this question later in the class or maybe in the next class, right? So we'll move on to other question. But meanwhile, you have enough information now to try the original question. Now that you know the simplified question is answered, I can erase off the 9 and then you can continue from here on. So as part of next homework, try this, right? If you don't get to discussing this today. Okay, so let's move on to question 8.
So we have to use the answer we got like right now for the
may not be. That's something for you to think. But concept you have to use. Maybe you'll use this number, maybe you might not use the number. That I'm not taking away the suspense, right? But you guys think. and then we'll discuss. I don't want to give free answer. Okay, that's question 7. Question 8. Why am I struggling with this today? Copy paste. Okay, what is the probability that 3 numbers A, B, C are selected? 1, 2, 2, 0, 1, 0. ABC plus AB plus A is divisible by 3. Okay, another slightly other difficult side of questions. Drishit, were you able to do something with this?
No, sir, I didn't get it.
Okay, Veer. Even if you did some partial progress, it's fine.
Could I figure it out?
Okay, anyone with some initial thought you can share? Suhani, Navya, Sanvi, Aditya.
No, I wasn't sure.
Okay. Okay, the question is clear. You have any thoughts? Okay. Okay, so the question is clear, right? ABC plus AB plus A is divisible by 3. Okay, so first of all, one good thing to notice is 2010 is exactly divisible by 3. So the numbers are all symmetric in terms of the remainder when you divide by 3, as in 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that, the last pair will end in 2008, 2009, and 2010. 2010 is exactly divisible. So you have exactly 1/3 set of numbers which leave a remainder of 1. So this is the remainder when you divide by 3. And this will be the remainder. These are the 1/3 set of numbers that will leave a remainder of 2. And 1/3 set of numbers are exactly divisible when you divide by 3. Okay, so the remainders are only 3 possibilities, right? 0, 1, or 2 when you divide by 3. So in a way, the problem is simplified for us. The 2010 is exactly divisible by 3. Therefore, there's symmetry buried in the problem. Okay, so far so good. Okay, now what is the probability that this, first of all, what is this? A into BC plus B plus 1. So the question is asking, what is the probability that this is divisible by 3? Okay, now we can make 2 cases out of it. Okay, first case, A is divisible by 3, right? A is divisible. Okay, I'll just say divisible by 3. It's understood by divisible. Okay, so A is divisible by 3, or A is not divisible by 3. Okay, so do we agree that this is 2/3 probability, that this is 1/3 probability? For A to be divisible by 3, it's 1/3 because you're randomly and independently selecting, right? So B and C could also be, and he says with replacement also, just to be double sure. He need not have said that. Independent itself means with replacement, because if you don't replace, there is dependence. Going back to one of the earlier questions, right, where Suhani answered that, if I remember right? The moment you don't replace, you're building dependence there, because you're picking a number has influenced that the second number cannot be that, which means there is influence, there is dependence. Influence is dependence, right? Okay, but independent is same as with replacement, but he is just being very kind and giving you explicitly randomly, independently, with replacement. Okay, so you have no doubt about it now that the 3 numbers can be same. For example, A and B can be same, C also may be same, may not be same. All those possibilities are there. For A to be divisible by 3, it's 1/3, because 1/3 of the numbers are divisible by, as long as A is in this last set, right, is divisible by 3. Now, why am I doing it with these cases? Because if A is divisible by 3, you don't even care about what B and C are. Automatically, the product is divisible by 3, because the product is, or rather the sum is factorized as A into something. Factorization means what? Factorization means writing as products of several units. So I've written as product of 2 units. A is 1 unit. BC plus B plus 1 is another unit. Factorization means writing a big expression as product of several multiplicative units. So here I've written that as product of 2 units. 1 unit is just A. The other unit is BC plus B plus 1. Okay, all of you good with me? So if A is divisible by 3, then the expression is divisible by 3. Now, if A is not divisible by 3, so the probability that we are seeking is with 1/3 chance. I don't even care what's happening to the rest of the world. Whatever B or C is, I don't care. Plus, if A is not divisible by 3, then talk to me, right? Then I'm going to come here and, okay, I'm going to do this part now. Right? This is all about B and C. So all about B and C, right? Are you guys clear with me so far?
So why 1/3 plus 1? 1/3 times 1?
Because with 1/3 probability, A is divisible by 3. So you're
Yeah.
saying if A is divisible by 3 and B and C are anything, I don't care. So the story goes like A is divisible by 3 and B and C can be anything of the 2010 numbers.
It will be divisible.
Yes, and hence into 1. And then you pause and then take a breath and say or, which is why you put a plus, right? You said A should be divisible by 3 and, which is why multiplication. And then or, A is not divisible by 3 and B and C have to do something now, so that the expression BC plus B plus 1 becomes divisible by 3. Okay, all of you with me so far? Okay. I'll erase all of this. Okay, so all about B and C. Okay, so which means, so we will focus on this part now. Okay, so now I'll just focus on BC plus B plus 1. Okay, so BC plus B plus 1. Okay, now, okay, actually there are multiple ways of doing this. The easiest way is, since there are only two numbers, B and C, we can list out all the possibilities, right? So what are the remainder? So there's only, so B, when you divide by 3, leaves a remainder of 0, 1, or 2. Okay, so I'll say B when you leave a remainder of, you only care about what the remainder is, right? So this is the remainder when B is divided by, I'll explain this once more, what I mean here. Just bear with me for a second. Okay. So there are only 9 possibilities, right? B, when you divide by 3, what is the remainder? Is it 0 or is it 1 or is it 2? C, when you divide by 3, what is the remainder? Is it 0 or 1 or 2? Right? And in each of these cases, we can find out what the remainder of this big expression is when you divide by 3. Okay, let's take one example. Let's say, let's do an example when I'll do this portion. When B leaves a remainder of 2 and C leaves a remainder of 1. So which means what? B is some 3m plus 2, right? And C is some 3n plus 1. That's what it means, right? When you say B is remainder of 2, it means it's some multiple of 3 plus 2. And C is some multiple of 3 plus 1. You are more with me? Are you with me, Ivam? Okay, so when you do the product B times C, it's 3m plus 2 times 3n plus 1. Okay, when you expand, I get 3m times 3n, which is 9mn. I get 3m times 1. I get 3n times 2. And then I get the final 2.
I didn't
Right?
understand 3n plus 2 and 3n plus 1.
Okay, you agree that B and C, when you divide by 3, can leave a remainder of 0, 1, or 2, correct? I'm taking just one example. When B leaves a remainder of 2 and C leaves a remainder of 1. A number which leaves a remainder of 2 when divided by 3 can be expressed as 3m plus 2. Do you agree, Navya? Okay, and 3n plus 1. So if B is 3m plus 2 and C is 3n plus 1, let's evaluate what the expression BC plus B plus 1 would be, or rather what the remainder when BC plus B plus 1 with divide by 3 give. Are you with me, Navya?
Yes, so good.
Right? So when you do the product BC, 9mn, 3m, 6n, all don't matter because they're all perfectly divisible by 3. I'm only talking about reminders. So effectively, BC is a remainder of just 2 when divided by 3. So effectively, it's just the 2 times 1. The 2 times 1 is going to matter for BC. So BC is just 2 times 1. And B itself is just 2. And the 1 is just 1. So effectively, this is a remainder of 5. Are you guys with me? All of you with me? So Navia's handshake. Navia's thumbs up. Okay, what about others? Suhani, all of you okay?
So can you just repeat 2 plus 2 plus 1? How do you get that?
If B is 2 and C is 1, I'm just literally doing the product BC. So I'm doing the expression BC plus B plus 1, which is 5. And 5 is effectively equivalent to a remainder of 2. When you say remainder is 5, when you divide by 3, how can the remainder be 5? It means subtract off more 3s until you get something in the range 0, 1, and 2. Right? When you say the number 20, when you divide by 3, you can say it's 15 plus 5. But do you say the remainder is 5? You don't, right? Because it's 18 plus 2. You can travel one more 3, right? And therefore, effectively, this is just a remainder of 2. Do you agree? All of you with me on this one? Okay, so like this, let's try to fill this entire grid. I mean, I'm saying this looks like a long process, but because I'm describing it to you in detail, it looks like a long process. Otherwise, it's very quick. Okay, so this here is 2. Okay, maybe I'll just fill this grid properly. I'll just make a proper grid, right? So it's easy. So this is, we can use the, so this is, we can use 0, 1, and 2. I don't have to be confused. So 0, 1, and 2. Okay, so let's fill all of these 9 numbers. There is this here. So this top portion is for B. So these are all B, and this portion is C. Okay, so right now we did, this is 2, right?
So
Yeah,
I'll have to leave because I have a class like right now.
no problem. But do watch the recording later.
I'll watch the recording. Yeah. Okay. Thank you, sir.
Okay, no problem. Okay.
I noticed a pattern to like fill it faster.
Yeah. Yes. Yes, Navya, I'll just come to that. Yes, that we can do it much faster, but I just want you guys to know the basic method first, and then you can always optimize on top of that. Okay, let's understand the basic thing, right? So BC plus B plus 1. Okay, so let's start filling. If B and C are both 0 and 0, so it becomes, let's start filling from the top left. So effectively, this is 0 plus 0 plus 1. So this is 1 here. If B is 1 and C is 0, so it's 0 plus 1 plus 1, effectively a remainder of 2. Okay, and B is 2 and C is 0, so it's 0 plus 2 plus 1, which is 3, and 3 is effectively same as a remainder of 0. Are you guys okay with this first row that I filled? Okay, second row, B is 0 and C is 1. B is 0, so this is 0, this is 0, and this is 1. So this is 0, this is 1, this is 1. B is 1 and C is 1. So the product is BC is 1, B is 1, and this is 1, which is 3, which is effectively same as 0. Okay, and then lastly, B is 0 and C is 2. So this is 0 plus 0 plus, sorry, B is 0 and C is 2, right? Yeah. And yeah, so if B is 0, then automatically this is all going to be 1. Okay. And B is 1 and C is 2. B is 1 and C is 2. So it's 2 plus 1 plus 1, right? BC plus B plus 1. How much is this? 4, right? Which is effectively a remainder of 1. 4 is effectively a remainder of 1. Correct me if I'm doing some mistake, guys. And then 2, 2. So 4 plus 2 plus 1, which is 7. But 7 is effectively same as remainder of 1. Okay, is this what you got as well, Navya, by your pattern method?
Yeah, I realized my pattern was wrong. Like I was only for the first number.
Okay, all right. But yes, we can optimize this, right, in many different ways. I don't want to confuse people just yet. Is the straightforward method clear? Even though it might seem like taking a little longer, I'm okay for now. If we get this one right, then you can always optimize later. Is everyone clear on this grid? Swani, are you with me completely on this? Swani, are you?
Yeah.
Okay, now, so now to go back and fill this guy all about B and C, I'll say if A is not divisible by 3, then this expression BC plus B plus 1 must be divisible by 3, and that happens with a probability of 2 over 9, because only in 2 cases of the 9 cases, BC plus B plus 1 is divisible by 9, is divisible by 3 of the 9 possibilities. So I'll just fill 2 by 9 here, and that's it. Problem is done. Are you guys with me on this one? So a simplification anyone can do. So 1 by 3 plus, so it's 1 by 3 plus 4 by 27, which is 13 by 27. Arav, you with me? Ranveer, did you understand this?
So how
Ranveer.
do you get 2.9?
Because we filled the grid downstairs here, right? So
Yeah.
this is what? What is this grid about? It's the remainder when BC plus B plus 1 is divided by 3.
Yeah, so how 2 upon 9?
Because there are 9 possibilities for B and C combination, the 9 on the grid, of which only 2 of them, namely this guy and this guy, are leaving a remainder of 0, right? Which means exactly divisible, right?
Oh, okay.
Yeah, makes sense?
Yeah.
Aditya, you
So
with
I
me?
still don't quite understand the remainder, the table where you put the 0, 1, 2.
Okay, I'll choose one example again and just okay. Can you just pick one cell out of that I can explain? When B is what and C is what?
When C is 1 and B is 2.
Okay, this one, right? So C is 1
Yeah.
and B is 2. Okay, in fact, I think that's what we picked earlier. Okay, let's arrive at this 2 in different way, right? So B leaves a remainder of 2 when divided by 3, which means, in fact, I have it here. B is a number which is 3 times M plus 2. Are you with me so far?
Yeah.
Okay, and C is a number which leaves the remainder of 1. So C is a number like 3n plus 1. You with me? Okay, now what is BC? BC is the product of 3m plus 2 times 3n plus 1. And B is just 3m plus 2. And then 1 is just 1. So we are talking about this big expression.
Okay. Yeah.
But what I'm saying is, in this big expression, there's a lot of unnecessary clutter. Whichever has 3 in it, anyway, is going to not matter, because when you're only interested in remainder when divide by 3. So 3m times 1, I don't care. 2 times 3n, I don't care. 3m times 3n, I don't care. What I do care is, because why don't I care about all this? All these are already divisible by 3. And therefore, when I keep adding these numbers, the remainder is not going to get affected. It's going to be 0, 0, 0 for them. Contribution from them. You're with me, Arav?
Yeah,
Okay. So the only contribution is going to come from 2 times 1, which is effectively the remainders that we had, right? The 2 and the 1. So the product of 1, 1. And similarly, in the next term, the 3m did not even matter. I could have just gone with the 2. And then the 1 is just 1. So effectively, this expression is leaving a remainder of 5. But 5, when divided by 3, is effectively a remainder of 2. Right?
Oh, yeah.
That's how I simplified each cell.
Okay. Yeah.
Okay. Aditya, you're all clear, right? Veer, you're okay on this one? Veer?
Yes,
okay, you can give an
little bit of trouble on you.
Okay, or you can give an electronic thumbs up as well, right? And sometimes I'm not looking at your faces. Okay, all right. So that's cool. Yeah, let's go on to question set. The new algebra question set. Can you all open that up? Homework set 7. Okay, first one. Real numbers, x and y, satisfy the equation x square plus y square equal to blah, blah, blah. What is x plus y? Okay, Arya, we're able to do this one.
I got answer as 2.
Okay, Aditya, how about you?
So I haven't solved homework 7 because of my exams.
Okay, all right. Arya, can you explain how you got your 2?
Okay.
You got 2 as well, Navya? Okay. Arya, go ahead. Good, Devam. Yeah.
So I brought everything to one side.
Yeah.
So I got x squared minus 10x plus y squared plus 6y plus 34 equals to 0.
Yeah.
Then I factorized that. So I got x minus 5 whole squared.
Okay.
Plus.
Yes, I know what you mean. You're not factorizing this. You're completing the square. So what he's doing, I'll take it from here. Right, good job. So x squared minus 10x, and then he's sensing that this can be a perfect square by adding a 25, right? Because if I plus 25, then it becomes x minus 5 the whole square. Right? So, but he cannot add 25 just for free. He'll add a 25 here on the right-hand side as well. Similarly, y square plus 6y, y square plus 2 into y into 3, plus 3 square. So he'll add a 9 here, and he'll add a 9 here. So that it becomes y plus 3 whole square. So effectively, he has x minus 5 whole square plus y plus 3 whole square plus 34 equal to 25 plus 9, which also happens to be 34, which means x minus 5 whole square plus y plus 3 whole square equal to 0. Aditya, are you with me?
Yes, sir.
Now, Aditya, can you help finish from here on? Suppose you have this, then what does this tell you? How can you finish from here?
So it's a square plus b square.
Yeah.
Is equal to 0.
Yeah. When is a square plus b square equal to 0?
So like, I didn't understand.
No, you're right. So this is a square, this is b square. When
Yes.
is product of two perfect squares 0?
So when both the squares are equal and negative, like,
But how can squares be negative?
yeah, so
And therefore, both must be 0 and 0. Because
Yeah.
both are 0 and above. How can the sum be 0 unless both are individually 0?
yes, sir.
Right? This concept keeps coming over and over again. Right? Therefore, this has to be 0, this has to be 0. Only then the sum can be 0. Therefore, x has to be 5, y has to be -3. That's the only combination possible. Right? Does it make sense? Okay. So, good job. Ranveer, you're okay on this one? Understood the method on this one? You can even...
Oh, yes, sir. Yeah.
Okay, cool. That was question 1. Question 2. Okay, who wants to go? Did you do question 2?
So no, I didn't get this. I don't understand what's that sign.
Yeah, that sign is something he has made up. So I can make up anything, right? Just so the signs, that popular signs that we all know is plus minus into division. So someone came along and invented some other sign like this, like a clever, right? The author himself has come up with some formula for it. I can come up with something. I can say tomorrow that A star B is A power 2B plus B power 3A, something like that. I can make up something for my own individual problem, right? So you'll see problems like this where the author has made up some symbol and defining a formula for it. Okay, Navya, did you get an answer on this one?
Yes, I got option B, one line.
One line. Okay, anyone agree with her or disagree with her? Arya, yeah.
I got 3. So
Got-
E.
3 lines. Okay, all right. Navya, can you tell me why one line?
So I solved the entire thing. Like I did x squared y minus xy squared is equal to y squared x minus yx squared.
Yeah, so let's do that together. So x square y minus xy square equal to the reverse, right? Xy square minus yx square, right?
Yeah.
Okay, and then how does it simplify? Yeah, go ahead.
And then I just simplified it further. So
Can you help me simplify this? Yeah.
I think you've written here now, man.
Okay.
It becomes x squared y minus xy squared is equal to minus x squared y plus xy squared.
Okay.
Then you can take the like terms to one side.
Yeah.
So x so you get 2x squared y is equal to 2xy squared.
Yeah.
2 and 2 gets cut. So
Okay.
then your x squared y is xy squared. You bring x to one side and y to the other side. So you
Okay.
get y.
So you get x equal to y. This is where your mistake is. Okay. He's right. Arya is right. So Navya, can you find your mistake from here on? You're okay till this step. And then coming from here to here, you messed up something. What did you mess up? And it's a common one, right? It's a common mess up. What did you do to get x equal to y? What did you do to get x equal to y?
Oh, you have to divide. If you divide the 2 with x, then even the y gets divided by x.
Yeah, that's fine. So if I divide both by x, I get xy equal to y square. And then you divide both by y after that, you get x equal to y. Seems fair.
Yeah.
When can you divide both sides of an equation by x? As long as x is not 0. But x could be 0 too, right? Okay. Or rather, in the simplification, what you should have done after this is you should have gone x square y minus xy square equal to 0. And then you should have taken xy common outside and then did x minus y equal to 0. And this is product of 3 separate units. X is a unit, Y is a unit, x minus y is a unit. Each one of them could be 0. X equal to 0 is a solution. Y equal to 0 is a solution. X minus y equal to 0 is a solution. You only got this one by dividing by x and dividing by y. You lost out on this and this. Does this make sense? Important lesson, guys, for everyone, all of you. It's very tempting to pick one line. The 80% of the kids would have picked one line. Well done then, Arya. Did you do exactly this, Arya? Did you get the x equal to 0 and x equal to y? X equal to y equal to 0 as well? Yeah.
That's exactly.
So it's 3 lines effectively, namely the entire x-axis, the entire y-axis, and the line x equal to y or y equal to x, all 3. Okay, all of you good? Suhani, you with me on this one?
Yes, sir.
Okay. Question 3. Sanvi, you're also okay, right, on this previous one? Okay. Sanvi, did you do question 3? Can you take this one? Real numbers A, B, and C. Sanvi Sheth.
Yeah, sorry. I did not do this one.
Okay. As in tried and did not get, or?
Yeah, I tried it and I didn't get.
Okay. What did you try so far? Can you take us through what you did so far?
I wasn't really sure how to solve this.
Okay. Veer, how about you?
So I tried to solve this and it led me on this very long journey that
Fine.
I'm
No
not
worries.
sure was right.
That's fine. Talk us through what you did so far. It's fine.
Okay, just a minute, pulling it up.
Yeah. Meanwhile, anyone with an answer? Anyone else has an answer on this? Okay, Navia's nodding. Arya, Yuvam, any answer? Okay. Veer, if you don't have something, it's fine. We can.
Yeah. No,
Yeah.
I've got it. It just loaded.
Okay.
Okay. So I said that the formula of an arithmetic sequence is an plus b, right? So assume a is unknown, b is unknown, and n keeps changing. We can say that I said that if C is A plus B, then B must be 2A plus B and C must be 3A plus B, since n keeps changing.
Okay.
And
One word of
I
caution.
substituted that into the equation.
Okay. The problem itself has small a, small b, small c. So it's not appropriate to keep an plus b. So if at all you want to do something, choose pn plus q. So that it does not.
Constants.
Yeah, of course, right? Otherwise,
Right.
you will get lost. Which constant is which one? Okay.
Right.
And after that?
So then after substituting, what I did was I factorized and I brought it to a general formula equation. Then I used the quadratic formula to find the roots of for the values of b. So I found the values of b. But then that was a very long process and I didn't get time to do post that.
Okay. All right. Fine. Okay. But good that you attempted at least, right? Okay. Now the learning will be like easier if you've attempted something, right? Rather than just coming cold. Okay. Let's do this. What you did was all good. But yes, as you rightly said, it will be a very long process. Instead, we could do something very simple. What is arithmetic sequence? You don't have to use big formula. Arithmetic sequence is uniform intervals, right? So in general, if there are 3 numbers, let's say I'm using different numbers than A, B, and C. If you have a number P, then P plus D and P plus 2D. We are only having 3 numbers, right? A, B, and C. We don't need N and all. N and all is needed if there is some big collection of numbers which are arithmetic progression. We literally have 3 numbers, A, B, and C, right? Arithmetic progression would be uniform intervals. Okay. Now, A, B, and C are in arithmetic progression. So instead of to help with symmetry, I'll keep P as B and C as B plus D and A as B minus D. Generally, this is preferred to help with cancellations. You choose the middle one, fix the middle one, and then aage piche you do plus D and minus D. Similarly, with geometric progression in another day, if A, B, and C were geometric progression, you would have picked B as B, C as BR, and A as B by R, so that the ratio is R, right? That's geometric progression. I'm just giving you on the side right now. So right now, back to this question. It's arithmetic progression. So let me just erase this to avoid confusion. So it's arithmetic progression. So this is my A. So this is effectively my A, and this is effectively my C. Okay. So now I have only three. B minus D, B and B plus D are the coefficients of the quadratic, right? Now, what does it take for the quadratic to have exactly one root? For a quadratic to have exactly one root, the discriminant must be 0, right? You remember this? So the roots were minus B plus or minus square root of B square minus 4AC, which is the discriminant, whole upon 2A. So if discriminant is 0, you remember this from the quadratic lecture, right? Veer, do you remember?
Yes, sir. I did use the discriminant, and that's how I got to the general formula.
Very good. Okay. So the discriminant is equal to 0 means exactly one root. Exactly one root. Or rather, it'll be two roots, but repeated roots, also known as repeated roots. Whoever is not clear, go back and review your quadratics, guys. Okay, repeated roots. If discriminant is 0, then the two roots are repeated. But what is the discriminant? Discriminant is B square minus 4AC. Okay. So B square minus 4AC, which is B square minus 4 into B minus D is your A. And then B plus D was my C, if you remember what we substituted for A and C. Okay. So this expression equal to 0. Okay. So let's simplify this. What do we get? B square minus 4 times B plus D times B minus D is B square minus D square equal to 0. So I'll take B squares all to the other side. There are minus 3B square, which goes to this side. And then there's 4D square, which comes here. So in other words, my D is just root 3 by 2 times B. Okay. Technically, it can be plus or minus. So in fact, I'll do that, right? I'll put.
I have a question.
Yes.
If B minus D isn't like A greater than or equal to B, and B is greater than or equal to C. So
Yeah.
shouldn't like C and A be switched? Shouldn't it be B plus D?
Yeah.
B
Correct. I should have picked B, but in this case, I'm going to finally say D is negative. Yes, you're right. Yeah, I should have picked. It would have been easier if it picked A as B plus D and C as B minus D, so that the sequence continues, assuming D is a positive quantity. But having finished this far, I will say D is therefore negative. Right? Are you okay with that? So D is negative. Right? D is minus 3 by 2 times B. But yeah, it's little counterintuitive. I agree with you. So ultimately, my A is B minus D, which is B plus B times root 3 by 2. So this is my A. So this is my A. And my B is just B itself. And my C is B into 1 minus root 3 by 2. Okay. All of you so with me so far? Arya, you with me? Okay. Now, what is he asking? What is this root? So what is which root? The single root, the exact one root, which means it becomes minus B plus or by 2A, right? So the single root is minus B by 2A. So it's minus B by 2 times A. And A is B times 1 plus root 3 by 2.
So wait, how did you get minus B by 2A?
Because D is 0, right?
Oh, yeah.
Yeah. Okay. So B gets cancelled. So it's minus 1 upon 2 plus root 3. Right? I can multiply and divide by the conjugate. So 2 minus root 3 and 2 minus root 3 here. So the denominator becomes 4 minus 3, which is 1. And the numerator becomes minus 1 times 2 minus root 3, which is root 3 minus 2. So root 3 minus 2 is this guy. Okay. All of you guys clear? Please do attempt all of these questions on your own later. Only then it's real proof that you understood what was happening. Here, everything will be obvious, right? Afterwards, when you do it on your own, that's when all these confusions will come. So please, please, please do all these questions on your own later. Okay, if you have not done already, that is. Even if you have done, I think it's good practice to do once more later. Okay, question 4. Maybe I think this might be the last question for the day. Let's see. Let A, B, and C be 3 distinct one-digit numbers. What is the maximum value of the sum of the roots of this? Okay, Sanvi, were you able to do this one? Sanvi, are you around? Okay, she's not around. Okay, who else? Suhani, you said you had exams, you couldn't do anything. Arav.
So no, I did not understand this, but I did some solving. I think it might be 16.
16, okay. All right. Arya, what did you get?
I got 16.5.
Okay, so the 16.5. Okay, anyone else? Navya, what about you?
I didn't get it.
Okay, what is the maximum value of the sum of the roots? Okay, so let's simplify this. So I can take x minus b common outside. Okay, so this equation becomes x minus b times x minus a plus x minus c equal to 0, which means it's x minus b times 2x minus a plus c equal to 0. Or in other words, I can write it as x minus b times, just to help write everything in terms of x minus a plus c upon 2 equal to 0. Okay, now what are the roots? The roots are clearly b is one root, a plus c by 2 is another root. Okay, now he's asking what is the maximum value if a, b, and c are three one-digit numbers. What is the maximum value of the sum of the roots, right? The sum of the roots is just, when I add these two, I get b plus a plus c by 2, which is nothing but a plus 2b plus c by 2. Okay, now I have to maximize this quantity where a, b, and c are three distinct one-digit numbers. So I can pick 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know whether 0 counts as one-digit number. Fine, let's say, but anyway, we are trying to maximize. So it doesn't make sense to pick 0. Either way, let's say whether included or not included. Now we have to pick a, b, and c as three distinct numbers from this collection. For example, I can pick, just randomly I'm saying, this could be my a, this could be my b, and this could be my c, for example. Right? But my goal is to maximize a plus 2b plus c, which means I'm inclined to pick all of them as high as possible. 7, 8, and 9 possibly. But which combination? So I can write this as a plus b plus c plus b upon 2. Upon 2 does not even matter because I'm looking to maximize this expression. A plus b plus c is all symmetric. So you don't care between 7, 8, and 9 how you allocate. But you do care because b has double weight. So you put b as 9. And between a and c, you don't care which you put to 8 and which you put to 7. That'll be the maximum. Okay, and what will that maximum be? A plus 2b plus c will that become 15 plus 18 by 2, which is indeed 16.5. Yeah, well done. I forget again who it was. Arya, was it you? Got 16.5. Yeah, well done. Does it make sense, guys? Navya, is it clear?
Yes, I got it.
Sanvi, you were missing in action for a couple of minutes. I called out your name. Is this clear to you, Sanvi?
Yeah.
Okay, all right, let's stop here for today, guys. But please do attempt the rest of the questions and whatever was pending. I know some of you did not even attempt. So for Ranveer, especially, I think you, Suhani, you also didn't attempt this homework, right? Please catch up, guys.
Yeah,
all
I'll
of you.
finish it.
All of
for
you.
next
Yes, I'll get it.
Okay, and watch the recording, guys. Chalo, bye. See you.